Hey, I just finished grading assignment on ozone, and the focus was mainly on ozone in the stratosphere. So this is an assignment that was due a month ago. So I apologize for the delay in getting some feedback to you, but I did work through it and gave you some uh, evaluations and feedback, and I thought I would give a little more feedback by this video. So if you have your assignment with you, you can kind of follow along. I just want to walk through it. And so the first item was on looking at what the textbook said about why ozone is harmful in the troposphere, and we followed that up with another ozone article or assignment. So there was a challenge to go see what was you could dig out of there, and some of the things that I was looking for in that item um, are that there was some harmful effects, and those are to living uh, things, including humans. Um, there also was a connection to pollution and creating smog. And then also a number of people caught the notion that it acts as a greenhouse gas. So those are some of the things I was looking for in that first item. Now, the second part, number two, was a little bit of a challenge to try to put the the idea of forming ozone in the stratosphere into 25 words. So you had to think a little bit about how to make that succinctly, and I saw some really nice examples, and I'm just going to read one of them. At, at 15 to 40 kilometers altitude, there's plenty of UV and oxygen molecules. UV dissociates oxygen into two oxygen atoms. These individual oxygens then react with oxygen to form ozone. So that was a response that hit the idea of the altitude, the ultraviolet light being present, that oxygen was present, and that oxygen atoms play a role in it. And so I liked that particular example, and I could have picked some other good ones. So that one had a bit of a challenge to think about how you could do it succinctly. In number three, wanted to highlight the role of oxygen atoms in the one mechanism for forming ozone in the stratosphere, and those reactive oxygen atoms are more abundant at those altitudes where the UV can split oxygen. So that's a rationale for why that's happening at that altitude. In the next item, the question came up about a catalytic chain reaction, and responses I thought that were quite good in terms of discussing this catalytic chain reaction was to mention either a series or a sequence of reactions, which carries this idea of a chain. And then the catalysis is one where a component of it is regenerated. So I was looking for something that tied to both of those two keys. Now this item 4, which had to look at the sink, is getting at a concept that I didn't really cover that well in class in terms of atmospheric species. And the overall idea is that you have a source and a sink for the presence of molecules in the atmosphere. And so they're kind of opposites of each other. A source brings molecules in, a sink then is something that would remove them. And I think a number of folks didn't pick up on the sink being a removal process and thinking more of a sink as being something that held and being more of a reservoir, but that would be not consistent with a sink being a mechanism for removal. So the focus in that item 4 was on the removal of chlorofluorocarbons and not so much as a reservoir. So I was curious to see what you could deduce about those kind of concepts. And I made it a challenge because the idea to deduce that from this scientific paper was a challenge. In item 5, talking about the polar sunrise, a lot of you caught this very remarkable thing that at the South Pole, there's only one sunrise in a year. Um, and then for 6 months, the sun is up and then it sets. And it's just such a radically different um, idea from our existence here at 45 degrees latitude. And so I was curious if some of you would catch on to that remarkable idea about the polar sunrise. In item 6, that one was having more with looking at some data and making some conclusions. So you'd think a little bit critically about some of the data that was there. In item 7, we had an illustration of forming the ozone with an animation of data over time. And I was pleased to see what some of you came up with in terms of how that is a useful illustration, and the role of scientists continually studying the ozone profile in the atmosphere by launching weather balloons on a daily basis. So that is a key to the fact that we even have the data. And then finally, in item 8, it's a bit of a challenge. There's the role of light in the ozone hole, and it's a little complicated just because when we have the solar darkness of winter at the South Pole, um, there is the formation, it gets cold enough for the polar stratospheric clouds, and that can accumulate some reactions on the surface. But then the role of light to take those reactions and create more active compounds, that was evident in the animation that light, once it comes, we have the polar sunrise, then we have this activity taking place. And um, so I was curious to see what we could all pick up in terms of the role of light in the ozone hole in the southern hemisphere in particular. And I just recently got a email from one of your classmates that reports on current Arctic ozone hole that was in place over this past winter, and that always is a much more rare condition, because the atmosphere has to form a vortex that's stable enough to cool the temperatures enough to get polar stratospheric clouds. So I'm interested enough in a few of those references to give you a link to some resources that help think about those things that are in the news. And those are the comments I wanted to make on this ozone hole. It kind of stretches out again our topic on atmospheric chemistry, and I'm going to continue to work on getting some of the things that I haven't graded yet back to you. So that's all for this particular assignment, and we'll stay in touch.